we need to find three numbers that are in geometric progression such that the sum of the product in pairs is 624 and their sum is 52. So let's begin. So we'll first consider the three numbers. Let these three numbers be a times r, and a times r squared. These three numbers are in a geometric progression. Now we'll use the fact that the sum, that is a plus ar plus ar squared, so the sum is given as equals to 52. And it's also given that the sum of the product in pairs, this is 624, so that means we'll consider the first term, multiply it to the second term, add it to the product of the second term and the third term, and finally add it to the product of the third term and the first term, and this adds up to 624. So using these two equations, we need to obtain the three numbers. So let's begin. Here we have a, so if we take a as the common factor, so we have 1 plus r squared, so this is equals to 52. We'll set it aside for the time being. So let's simplify the second equation. So here we have a squared times r plus a squared times r cubed plus a squared times r squared. So this is equals to 624. Now we were going to take a squared times r as the common factor. So we're going to get 1 plus r squared plus r. This is equals to 624. And we can further simplify this. So we have, if we take a times r and multiply it to a times 1 plus r squared, and this is equals to 624. So here we can replace a times 1 plus r squared with the value 52. So we have ar multiplied to 52. So this is equals to 624. Now we have ar equals to 624 divided by 52. So ar will be equals to 12. So we can rewrite r in terms of a. So r will be equals to 12 divided by a. So we will set this aside. Now what we'll do, we'll use this value to find out the value of a by substituting r equals to 12 over a in this particular equation. So here we have a multiplied to 1 plus r, so r will be 12 over a, plus r squared will become 144 divided by a squared, so this is equals to 52. So multiplying with a, we have a plus 12 plus 144 divided by a equals to 52. Multiplying throughout with a, we have a squared plus 12a plus 144 equals to 52a. We'll transpose 52a to the left hand side and combine it with the second term, which is plus 12a. So this is going to give us negative 40a. So a squared minus negative 40a plus 144 equals to 0. Now this is a quadratic equation. We can split the middle term. So we have a squared. Now we can split the middle terms in such a way that the coefficient of a squared here is 1 and the constant term is 144. So 1 times 144, that's equals to 144. Now we can also rewrite 144 as the product of 36 times 4. So 36, and we are choosing 36 and 4 in such a way that we can be used to split the middle terms. So here we'll have negative 36a minus 4a plus 144. This equals to 0. Which will give us a multiplied to a minus 36 negative times 4 times a minus 36. That's equals to 0. We're going to get a minus 36 times a minus 4 equals to 0. So that means a could be either 4 or it could be 36. So we have the value of r here. So let's use the value of r. Now when a is 4, then our r value is going to be equals to 12 divided by 4, so that it will be equals to 3. And then when we have a value equals to 36, then r value will be equals to, the 12 divided by 36 will be 1 over 3. Now we can use this to obtain the value of the three terms. So we will obtain the value of a, ar and ar squared. Now a value, that's simply 4. Then ar will be 4 times 3, so that will be 12. Then we have ar squared, that means 4 times 3 squared. So 3 squared is 9, 9 times 4 is 36. Then we will use a equals to 36 and r equals to 1 over 3. So a value will be 36. A times r, so 36 times 1/3, that will be 12. And 36 times 1 over 3 squared, which will be 4. So these are the three numbers that are in geometric progression, and we have 36, 12 and 4. This is also is a geometric progression.